In this example, we look more closely at a test method that evaluates the efficiency of cutting fluids for aluminium alloys. So aluminium alloys and in general lightweight alloys are of more and more interest in the industry. They can be used in vehicles and it can really improve fuel efficiency. But the cutting fluids that are used in these processes have to be tailored a little bit to the alloys specifically. So our challenge is to modify a standard test method that will simulate more closely the materials involved in these cutting processes. Our reference method is a tapping torque method. The tapping torque methodology is using a real tapping tool and is performing a real cutting operation, as you can see it right here, and is therefore the closest simulation of cutting in practice. So with this method, we are evaluating three aqueous emulsions, lubricating emulsions in aluminium, and we will use that as the reference. The method that we want to improve and fine-tune is an existing test method. It's the ASTM D3233A, also known as the Falex Pin&Vee Block machine, or sometimes known as the Falex test. It is a method that exists already for quite a long time and involves rotating a journal pin in between two V blocks that are pressed against it with an increasing force or an increasing load. And the whole contact is lubricated by a small oil bath. And as we are increasing the load, we can monitor the torque that is performed on the pin. And we can also see at what load the system fails, at what load the lubricant can no longer sustain the load. So that is in a nutshell the ASTM method. But it uses steel specimens as the materials, and it is using a limited amount of oil. The modifications we have made to this methodology are, on one hand, let's reduce the sound there. On the one hand, to spray an aqueous emulsion directly in the contact, as you can see it here. And this has the advantage that we can use a larger volume that we are recirculating, and this keeps the temperature under control. It is also making it easier to clean the contact, to remove any chips that may be forming themselves. So all in all, it is a closer simulation to a real cutting process. We are also modifying the test specimens. Instead of steel specimens, we are using aluminum alloys as the pin material. And we can use hardened steel, or if we want to, we can use coated steels as the V blocks to have a better representation of the tool. So in a nutshell, with the recirculating aqueous emulsion and measuring online friction force, we are hoping to get a bit closer to a simulation of a cutting operation. So what are typical results with this method? We are showing here the torque versus load curves for water without any lubricant in it, and a cutting fluid that is an aqueous emulsion that is made out of increasing percentages of cutting oil dissolved in water. As you can see in this graph, the purely water lubricated system breaks down fairly soon with quite light loads and has a high torque. The emulsions with 2.5 and 5% cutting fluid will survive to a higher load, and the emulsion with 10% cutting fluid to an even higher load. And also progressively, the torque, the frictional torque, is lower with an increasing amount of cutting fluid. How do these results compare to a real cutting operation in the microtap test? Well, these are the results of the tapping torque test with the same fluids. We see that the pure water indeed, as expected, gives the highest torque in a cutting operation. And then there is a gradual decrease of the torque with increasing percentage of cutting fluid in the emulsion. And when we plot our Pin&Vee block results next to it, we see a quite good almost perfect correlation between the torque in a Pin&Vee block test and the torque in a cutting test. So the changes that we made, the modifications that we made to the standard method result in a closer simulation to real conditions of cutting with the aqueous emulsion that cools and cleans the contact and using the real alloys in the contact. And it also, very importantly, of course, correlates with the practice as is proven by the tapping torque results.